Since 1980, Abtex has been custom designing high-quality deburring systems to deburr and improve the quality of its customers' parts, while also streamlining their operations. In 2022, a highly successful OEM approached Abtex with a new deburring challenge. This OEM designs and produces high-reliability parts, specifically for the automotive market. OEM parts are becoming more sophisticated, with greater demands for precise surface finishes, stringent tolerances, and rapid processing requirements. Abtex engineers developed this system to help their customer exceed their production expectations, while providing a consistent and dependable deburring solution. This deburring solution is based on the Abtex Tri-14 deburring system, with dual planetary heads. Each planetary head utilizes three 14-inch quick-change deburring brushes. The system features a proprietary automatic brush wear compensation system, allowing manufacturers the ability to reduce their consumable cost and maximize the longevity of the brush. Abtex's unique planetary head action ensures that each part is completely deburred and radiused per specification. The deburr results are unparalleled. The system can accommodate either manual or automated loading for most parts. Parts are loaded onto a magnetic conveyor and guided through both planetary heads, where their top surface is deburred. They are then transported to a unique magnetic rollover drum, where they are flipped and prepared for precise deburring of the opposite surface. Each part is then rinsed and demagnetized before exiting the system to return to a pass-through conveyor to complete the process. The entire process is controlled through a user-friendly HMI screen. Individual part recipes can be stored and recalled for future ease. By incorporating precise, high-speed deburring into their operation, this Abtex customer is now able to achieve a continuous flow to their production line to meet their customers' demand. Brush deburring began with Abtex, and Abtex still leads the way. Where machine, brush, and burr intersect, Abtex dominates.